Good day, lecturer and classmate. Today, I will present our IoT shelter comfort system. Our goal is to monitor 7 shelters, temperature and humidity, and auto-control cooling and heating using DHT11, Wi-Fi, not RED, and a real-time dashboard. Manual monitoring fail to suit different animals' environmental needs. It is slow, error-prone, and case animal stress and illness. Our IoT solution offers round-to-clock sensing, automatic climate control, and a unified live dashboard. Our closed-loop system works in 4 steps. DHT11 sensor gather data, note IED process reading, the system check against specs, comfort threshold, and header cooler turn on automatically. Live data is shown on the dashboard via web socket. One platform manage 7 shelter. It support real-time precise monitoring, automatically climate switching, instant fall alert, live and historical data chart, and low latency web socket data transfer. The system detects small environmental shift and run fully autonomously 24/7. It delivers non-stop monitoring, self-adjusting climate, instant critical alert, live dashboard update, and separate control for every shelter unit. Current limits include inaccurate DHT11 sensor in extreme weather, Wi-Fi relays, and static threshold logic. Later we'll add AI prediction, cloud data storage, mobile alert apps, and more stable MQTT communication. This IoT system updates animal shelter management. It improves animal welfare, cuts manual labor costs, and provide a scalable base for future smart farming and AI animal care. Thank you for listening. I will pass to my next partner.
Hello everybody, today I will explain the system we built using Node-RED. In the beginning, as you can see here, the structure of the system, okay? We have 7 different type of animals, as you can see here, which is dog, cats, rabbit, pig, and sheep, and cow, and finally we have horse. We organize them like this, as you can see here. Now let's move to the structure of the system. As you can see here, there's main thing I have to explain first, like the judge. As you can see here, we put the range of the animal temperature, okay? And based on this temperature, it will show us in the judge the situation the animal in. And we have here the switch to know the temperature for every single animal, so the system can act based on it. For the humidity here, we use this code, simple code, not complex, to send notification for the users about the animal situation. Here we have put the minimum and the maximum for the judge, so it can appear. And again, for temperature, heating on, cooling off, it will send a notification for the user that the heating or the cooling button is on or off, as you can see here, okay? It's the same with every animal, as you can see here, but every animal has a different limit. Like here, the cat, it has different limits. The same thing here with function, it has different limit, as you can see here, the humidity. But the structure the same to be more organized. Okay, now let's jump to this, which is the main page, as you can see here. Okay, here, as you can see, it's the main board for every single animal. Okay, for group 1 we have dogs. Let's say, for example, the temperature is very low of this temperature. Okay, as you can see here, it will send notification. Okay, so what the user should do is immediately switch the heating on. As you can see, it appear notification here. Okay, after that, let's say the animal temperature has raised up to the normal. As you can see, it will appear a notification that it's in normal temperature. After that, there's no need for the heating. As you can see, after we turn it off, it appears a notification for the user. And it's the same here. Let's say it's about to get high. Okay, it will send as well notification for the users, as you can see here. If it is get high, the users simply can press the cooling, for example, cooling on, okay, and cooling off. Now, if everything returned to normal, it will appear a message for the user. For humidity, the same situation here. The humidity is normal, it says it normal, okay? But if it is low, like this, it will show alert that the animal humidity is low. So in this situation, the user, all what he have to do is to press cooling button to fix this situation. Here's alert that it's getting low, okay? But it's normal to raise up when we use the cooling to fix this situation. After that, when it's back to normal, it shows that it's normal, so there's no need for the cooling. As you can see here, the notification that it's off. And lastly, if the temperature get high, it will appear the humidity level is high, okay? So what's the user should do in this case is press the cooling, which is on, or the heating, okay, based on the situation of the animal. Okay, so let's say heating. Okay, if the animal situation returned to the normal, it shows that it's normal situation. Okay, so what you have to do is just turn it off. The same case here with all this animal, the cats, normal, it's okay. But if the temperature get low, we start the heating, and every single step we do has sent a notification to the users so they can know the animal situation. Okay, after it get to the normal, we turn the heating off. It's get high, we turn the cooling, and like this judge, okay, it's based on the temperature of the animal in that situation. Okay, and the same idea here with the humidity, as you can see here. In every situation, it will send a message for the user. Okay, that's the same way for the rest of the animal. Okay, thank you very much. That's all.